Welcome to 2.3 Computing Limits. What you're looking at right here is a chart of n behaviors, and the first thing is we have f of x equals x. Limit as x approaches negative infinity would just equal k. And then the same thing for when it approaches infinity. And then the graph is just a horizontal line because it's always just a number. And then f of x equals x. The limit as x approaches negative infinity is negative infinity. Limit as x approaches infinity is infinity. And then that's what your graph looks like. And then you have f of x equals 1 over x. Both your limits there are 0. And then you got your graph to the right. And then for your examples, you have the limit as x approaches infinity of x plus 5. Your limit is infinity, because if you plug in infinity, you get infinity plus 5, and that's always going to be infinity. And then your limit as x approaches negative infinity of x minus 4 is negative infinity, for the same reason as the previous one. When you plug in negative infinity minus 4, you're always going to get negative infinity. And then the limit as x approaches infinity for 6x is also infinity.
Okay, so in this example, we have the limit of x as it is approaching infinity of 5/3, and there's no variable x in this equation, so our answer is just going to be 5/3, because even though x is approaching infinity, it's a constant. The next example, limit as x approaches infinity of negative 3x plus 2. This is just going to be negative infinity, because you got the negative 3 times an infinity, and that's just going to make it negative infinity, and then adding the 2 isn't going to do anything. It's going to keep going. And then you have x to different powers. So for the first one, limit as x is approaching infinity of square root of x, that's x to the 1/2. That's just going to be infinity, because as you keep putting in numbers in that equation, it's just going to keep going higher and higher. And then for the next one, you have the limit as x is approaching negative infinity of square root of x, and it's negative infinity, and when you take the square root of negative, it's that number doesn't exist, so the limit doesn't exist. And then the next one you have is limit as x is approaching negative infinity of the cube root of x, and when you do a cube root, the sign is going to stay the same, so it's going to be a negative infinity. And then for the next one, the limit as x is approaching infinity, the fourth root of 3x plus 2, you just go right into it and put the infinity in for the x, so 3 times infinity, that's just infinity, plus 2, once again, it's not going to have any effect, it's just going to be infinity. And the fourth root of infinity, that graph is just going to keep going up, so you've got an answer of infinity.
Alright, this is your n behavior graphs. Your odd polynomials are basically if you have an odd number leading, then it will have an even number of turns. And then for even polynomials, if your leading number is even, then it will have an odd number of turns. So for the even, it will start and end in the same direction, and for the odds, it will start and end in opposite directions. And then the maximum number of turns the graph can have is just n minus 1.
Okay, so now we're going to go into some examples. First example we have here is the limit as x is approaching infinity of x cubed minus 50x squared. And this is simple enough. You got infinity cubed, so that's going to be, infinity 3 times. That's going to be a big number, minus 50x squared. So you would think minusing is going to make it negative, but the x squared is less than the x cubed, so it's just going to be positive infinity. Our second example is the limit as x is approaching negative infinity. And you plug it into that equation, put it in for the x squared, and you get negative infinity squared, which is going to make it positive infinity. And then you're multiplying by negative 4, which then flips it around, makes it negative infinity, and then adding the 30 isn't going to affect our x value, because it's just going to keep moving in that direction. For number 3, got limit as x is approaching infinity of 6 plus 1 over x. Now you can split that up, that's one of the rules, so you just take the limit as x is approaching infinity of 6, which is a k. And limit of that, a limit of a k is always just a k, so that's 6. And then you've got the limit as x is approaching infinity of 1 over x, and that's just 1 over infinity. So that number is just going to keep going up, and it's going to be lower and lower fractions, so that number is approaching 0. So you just get 6 plus 0 equals 6. And then for our next example, we have limit as x is approaching negative infinity of square root of 5 minus x. So you just plug it in, look at it as 5 minus negative infinity, so that's like 5 plus negative infinity. Just in infinity, square root of infinity is infinity. The next one, you got the limit as x is approaching infinity of the square root of 5 minus x. So similar to the last one, except it's approaching infinity. So we're going to have 5 minus infinity. That's going to be a negative infinity, and the square root of a negative does not exist, so the limit does not exist. And then for the last one, the limit of x as x is approaching infinity of x squared times 3x plus 6. So you just infinity squared times another 3 times infinity plus x. That's just going to be infinity times another infinity and another infinity, and it's just going to be infinity.
Alright, we got some more examples, and these are all called rational functions. The first problem here is the limit as x approaches infinity of 6x plus 5 over 7x minus 20. And what you're going to want to do here is multiply the top and the bottom by 1 over x, so that way you can cancel out the x's, and then you just get constants, and then you get your 1 over x rule, which in this case is going to be a 5 over x and 20 over x, and then that's just going to be, and you know that limit as it approaches infinity is always 0, so that is easy to work with. And then, so if you do that, you get the limit as x approaches infinity of 6 plus 5 over x over 7 minus 20 over x, and that's going to equal 6. The limit of all these is just going to equal 6 plus 0 over 7 minus 0, and that's just going to get you 6/7. And then the next problem, you're going to want to do basically the same thing. Multiply the top and the bottom by 1 over x, and then that's going to get you the limit as x approaches negative infinity. That's going to get you 3x plus 2 plus 6 over x divided by 1 plus 3 over x. And then the limits of all those are going to be negative infinity plus 2 plus 0 over 1. And then the limit of that's just going to be negative infinity because that cancels all the numbers out. And then the limit as x approaches negative infinity of negative 6x to the 4th plus 3x plus 1 over 2x squared plus 7x. What you're going to want to do with that is the same thing, except this time multiply the top and the bottom both by 1 over x squared. You're doing that for the same reasons. You want to get that constant and make it so you know the limits of easier numbers to work with, and then that will get you negative 6x squared plus 3x plus 1 over x squared over 2 plus 7 over x. And all those limits come out to negative infinity plus 0 over 2 plus 0. And all those numbers cancel out, and you just get negative infinity for that one.